Alright, so hey everybody, this is Project Polar Heating and Air's doing. We're going to give you a little before, during, and after, and a little explanation of what we're doing as we go through. So the first part of it is, you see here, this is a pretty big house. It has 6 bathrooms. It has, a lot of the bathrooms have you know, body jets, shower heads, jacuzzi tubs. You can imagine there's quite a volume of hot water when it's all on. So right now there's this tank. Tank works good, but it's reduced draft motor that's been repaired 2 or 3 times, and it's kind of on its last legs. This is a recirculator leg that goes into it. So this is the existing, and actually, it works okay. Obviously, if there's a lot of people using hot water, this has a little hard time keeping up. But I mean, it's 6 bathrooms with shower jets, heads, and jacuzzis. So this has been wonderful up to a point, but it's been repaired 2 or 3 times. I want to say this house was built around 2011, 2012, so it's not that old. So what we're going to do here, if you see here, we had some of our crew, we put plywood up here, and when the house was built, there were these PEX tubes. These PEX tubes go up into a garage area. These PEX tubes go into the floor, the radiant floor. So what we're going to attempt to do, not attempt, we're going to do it one way or the other. We're going to take all this hot water tank out. You see there's already a gas line and stuff stubbed in here, and the tubing's already in. So next part of the video, because we had nothing to do with the building of this house, and we don't have the prints, and we don't have the information for the company that actually laid the PEX tubing. So what we're going to first do is we're going to try to figure out the length of the PEX tubing and where it runs. And how we're going to do that, you're going to see a video in a little bit. We're going to have everything connected, where we're going to connect supply and return water to this. We're going to have a bucket full of water that's on a scale. We're going to use a pump, and as we pump the water through, as it goes all the way through into the bucket, that bucket's going to lose weight. It's going to lose a certain amount of pounds and ounces. We have our guy here, Mike, has done a little math. This is a 5/8 inch diameter tube that we're using. So once we know the weight in ounces of the amount of water that's now in the loop and no longer in the bucket, based on the reading on the scale, we're going to multiply that by whatever the factor is, and that should give you our linear feet. Also, we have a camera that's an infrared camera. I don't know how well it's going to work because you know, we're going to use hot water out of here, but we're not going to have a ton of hot water. So hopefully we'll be able to use that infrared camera to also see where these tubes are running, just out of curiosity. Either way, we're hooking it up. But the new system, instead of having 1 tank and these not hooked up, is going to be 2 Navien boilers. One is going to be a combi boiler, and what that means is one side of the boiler will do this radiant heat, which isn't much, I don't think. The other side of the boiler is a tankless hot water heater that's about 180,000 BTUs. We're going to connect that to another tankless that's strictly for hot water. That's 200,000 BTUs. It's going to have a communication cable in it. So what that means is that the one boiler will always be ready to do the hydronic, but it'll also have a backup for the domestic hot water. The main one, which is 200,000 BTUs, that'll be a faucet, and it kicks on. We're going to hook the recirculator line up to it. That has a little buffer tank. I'll explain that more. But bottom line is, we're going to have 2 hot water tanks here now that are tankless. So we're not going to have to heat water when we're not using it, which gets kind of expensive. We're only going to the hot water tanks modulate up and down. So if you only need 8,000 BTUs because you only got 1 sink running, you're not running this to heat up 75 gallons of water to just feed 1 tank. So it's going to run exactly what we need it to run. Nice part about that is, because we're going to hook up the combi boiler to it, if people are over, there's a party or something's going on with the people who live in the house, and you're starting to run out of hot water just because the volume's kicking out, there's a sensor in the combi boiler, and it's going to tell it when the main hot water heater is 80% of its capacity. It's going to open a valve and it's going to kick on the hot water from the other one. So basically, it's going to run exactly what it needs. But if you ever got everything going and you're maxing out your hot water, there's going to be a thing that says, okay, your other one's at 80% capacity, is about to run out of full capacity for hot water, turn the other one on. Nice part about that is, let's say you do have a problem where you have an error or you have a breakdown in your hot water heater, you've always got backup hot water. So you got kind of the best of both worlds. It's 96% efficient. You get all the water you want whenever you want it. And if one does break down, you still got the other one as a backup till you can, call Polar Heating and get it fixed. So that's kind of the project we're doing in a nutshell. I just want to go over it with you. And you see what's here, and then, we'll flash some pictures at the end of the video to show you this versus the new installation once we go through all the steps. So thank you very much. We're going to turn the camera off now, and we're going to get to hooking up and testing the volume of water in the loops and trying to figure out linear feet of loops, just because we want to know. Okay, so we'll see you. We'll see you in 2 seconds, but on our end it's probably gonna be 2 hours. Okay, so we're back here now. We took a little bit of time. You can see what we did is we clamped off a one hose to go to supply, one hose to go to return. We've got 2 buckets of water that have each one has 40 pounds of water in it. We have a digital scale. This is actually a refrigerant scale on a pump. So we actually already did 40 pounds. And it came, and so which is 5 gallons, which we did not have actually enough water in here, so we had to add another bucket to it. So right now we're pretty sure that even though that says 40-foot lines, that's 300 feet, which is a good thing because that means it covers most of the garage. Which also means when we do install the Navien Combi-Boiler, because it's not just a small area in the back of the garage, I'm definitely going to make sure that we hook up a glycol feeder tank to it for freeze protection, because it's going to be an area where you have an outside door open and closing. So we'll show you all that in a later video. But right now we've kind of got it all set up. We're pumping it. We went through one. We know there's more that holds more than 5 gallons of water, 40 pounds of water, which based on, there's everyone in the background there, Mike, one of my guys did some math. He did some mathematical calculations, which tells us we're already close to 300 feet. So we're guessing once we get this 5 in and then we add more, that we're going to be right around 300 feet with that loop, which is good because it tells us, again, it tells us it's the whole garage, it's just not a little section. So again, we're doing a little bit of detective work here before we connect everything, just to make sure that we have the right size boiler, the right manifolds in. We were gonna, if that was really only 40 foot of loop, we were going to put an extra opening on the manifold, so instead of just having one zone on the manifold, we're going to put a second zone on the manifold, so that eventually, if we wanted to, or the homeowner wanted us to, we could add either radiant heat, or we could add some type of fan, hot water fan coil to heat the garage up to 60 or 70. But it's looking like we're not going to have to do that. It's actually looking very good. So didn't make sense that it was 40 feet. The loops come in 300-foot rolls, so it's kind of stupid just to run 40 foot of line. You might as well run a rollout if you're going to do all that before you pour the concrete. So I'm actually pleasantly surprised that the people who did it, it makes some sense now, and it didn't make sense they ran 40 foot of line. So we're gonna, that's gonna be the end of this video. We're gonna figure out, we're gonna continue measuring the water, we're gonna do the loops, we're gonna figure out where they're at. The next part will be when we're actually doing the install, and then it'll be after it's done, and we'll give the final explanation of what happened, where we ended up with on linear feet, where the actual loops are in the house, and how everything got all plumbed in and connected. And it's a really cool system. So we'll probably see it in about a second, but probably about a week we'll actually really be filming the rest of this. So see you in about a second or a week, depending on where you're at in the universe. Thanks. Bye. Okay, so first part of the video we showed you what was here, we explained what was going on. Just a little recap. Now that it's done, I'm going to walk you through everything we did. Basically, we had a tankless, we had a big tank, commercial grade 75 gallon quick recovery hot water tank here, storage tank, not storage tank, gas hot water tank with a recirc line tied into it, okay? So what we did now is, but also if you look over here, and I'm going to explain this well, we had this PEX pipe that was going to the garage, we had a PEX pipe that was going to the floor. So there was radiant in the floor to the garage in the basement that was never hooked up. So first let's talk about the domestic hot water. First thing we did is we put in this, and this is a 199,000 gallon tankless hot water heater, instant hot water. It's got a little small pump on it, and it's got a recirc line. So this will recirculate the water. So if this is a big house, if you're in like the farthest bathroom, like way upstairs, you'll have instant hot water instead of waiting 4 or 5 minutes. So this comes with that extra, it's got a pump and it's got a small tank. just to keep the water warm in the house. So basically the hot water, the cold water comes in, this is on a well, comes in through here and feeds down and then goes out into the domestic hot water line. This is the recirc line that's plumbed back in from all the fixtures that goes into the pump that circulates the water. Then over here, as you move over here, this is actually a combination. This is a boiler and a tankless hot water heater. So this will also give you another 199,000 BTUs. So what that means is at a 77-degree temperature rise, it'll give you somewhere around 6.4 gallons per minute, which is enough for 2 showers, a sink, and maybe to run the dishes. So one of these will do that load normally, okay? But this house is kind of fancy. It's got a bunch of whirlpool tubs. It's got 6 shower heads. It's got body jets. So what we did too is we plumbed in on the domestic hot water side. This side also does the same amount of hot water as the tankless hot water heater does. What we have is we have a slow closing solenoid valve. So what happens is this has a communication cable, and the way Navien works is normally this is the only thing that's going to fire and when you need hot water. But what happens is this communication line says when this gets to 80% capacity, it tells this one to open that valve and then double up so the capacity. So most of the time, I had this in for a month before I got the rest of the system hooked up. I was told there was absolutely no problem with hot water at all with just the one. So if you've got people over, guests staying, and that, the nice part about this is it does 2 things at once. In a lot of houses, you only need one of these for both your heating and your hot water. So when that gets to 80% capacity, it tells this one to kick on the domestic hot water. That valve opens up, and then you got double the hot water. When stuff gets turned off, you don't need them both firing. This will shut down, and the other one will kick on. Also, this one will tell this computer board, will say, hey, this one's been working for a month straight. This one hasn't kicked on once. Let's make this the primary to kick on for a while, just so you don't overwear the one system. So you have the benefit of only using, if you got one faucet on, not only will this be the only one to run, it will modulate down to the BTUs you need just to do the faucet. So it's 96, 97% efficient, but it also only fires at anywhere from 18% up to 100%, depending on the amount of water you need. So it's very economical, but you have all the hot water you're ever going to need. So then moving over to here, what we did is this other side here, you see we plumbed, and this is the hydronic side, and this takes care of the heating. So the garage, we had to figure it out, and we figured it out by a water test, which I believe we showed on the video, that all these loops are 300 feet. So the garage loop is 300 feet. So we have basically, we have the hot water comes in, gets fed through here. This is a take-go zone valve. When the thermostat says, it calls for heat, it lets this valve know to open and let water flow through and to kick the pump on. When the pump and that starts working, then the boiler fires and it heats the water. And it'll only go through the garage if that's the only thermostat that's calling, right? It's separated out by this zone control valve thing. If you look down here, this is the take-go valve, and that controls there's 2 300-foot loops. There's a total of 600-foot, supply and return in this basement. And this will let it know there's a thermostat in the basement just for the hydronic heat. So if you've ever had hydronic heat, it's a lower temperature, it's super comfortable. It's going to radiate from the basement all the way upstairs. You're not going to have, basements are normally always colder than the upstairs unit. It's going to be super comfortable down here. You'll be able to walk in your bare feet. There's fancy showers and bathrooms and a bar and all that type of stuff in this basement. We're just in the mechanical room. So basically this is it installed. You've got your tankless hot water heater. You've got your Combi tankless hot water heater, high efficiency condensing boiler. It's all tied in together. One will kick on when there's not enough capacity on the other, yet it won't run when it doesn't need it, so you're not wasting gas. And the other one sits idle, and when there's a call for heat in the garage or in the basement, this will kick on, circulate the hot water through the pipe. So this is the nicest system as you can ever buy. The thing you can see here, if you're curious, basically this is a This is a fill tank, and because we're doing the garage, instead of tying it to regular water, we wanted to basically do an antifreeze system. Just because it's in the garage, we don't ever want, if for some reason that zone, we had a problem with the controller or zone or the boiler, we don't want that water inside those pipes to freeze, because then you got to bust up concrete and all that. So if you put a little fill tank and you put antifreeze in, never mixes with the domestic water, it's completely separate, it's isolated. But if it ever, for whatever reason, if you don't have heat out to the garage, you don't have to worry about the pipes and the concrete breaking. And you know, you have to do it for both if you're going to do it for one. So this basically makes sure that, like, the pipes in the ground has to get 100 blows there before they're going to break, which if that happens, we're all in trouble anyway. So hope you enjoyed the video. It's Polar Heating and Air. Go to polarheatingair.com. We'd love to come out, look at your project, and give you a free estimate, and you know, maybe sit down and explain this in more detail to you. So thanks for watching. Hope you got something out of it. We're really proud about the way this turned out, and the homeowners absolutely love the system. So thank you very much. All right, can you say hi? Wave, say hi. Wave. Hi, say hello. Hi. So we were about to leave, but we needed a testimonial, and the homeowner came home. This is little Michael. This is your grandma and grandpa's house, right? Okay. How do you like it? Up or down? Can you do a thumb up? Yay! Thumb up! High five. So we got a testimonial here. Michael likes it. Mikey likes it. All right, thanks. Bye.